hello everyone, I'm Chuan So from the University of Hong Kong. In this session, actually before lunch break, I will talk about our past project called the Night Sky Brightness Monitor Network, or NSN. Then I will also share some experience on data reduction and the requirement for you to set up the SQMLE station. So the project, or NSN in short, is a citywide survey of light pollution in Hong Kong, and we are going to study the long-term condition of night sky brightness, or NSB, in different locations in Hong Kong. And NSN established in 2010, and it is still working. And we are going to answer the following questions, such as the time variations of NSB and the geographical variation of NSB. Also, we are going to study the correlations between cloud amount and NSB. Also, how the moon affects our data. And NSN also acts as a platform for education, for light pollution information for students and teachers. And lastly, since there is no law or regulations on use of external lighting in Hong Kong so far, so we are going to use our findings for the government when she is drafting the regulations of light pollution. So we will talk a lot on this device. I will show you some technical details of this device. As we said before, it uses a semiconductor sensor to measure the light from this side. And this is small in size, and it operates in low voltage direct current. And this device gives NSB in the units of magnitude per arc square. I'm not sure whether you are familiar with this unit. Have you heard this unit before? Magnitude per arc square. Maybe I can talk a little bit more about this. MAG, or magnitude, is the unit of astronomical objects, the brightness of the astronomical objects. The unit is special because smaller value represent brighter source. Smaller value represent brighter source. On the other hand, the larger NSB value represents darker sky. And the arc second is the size of a sky patch in the sky patch, and actually 1 arc second equals to 1/3600 degree. 1 arc second equals to 1/3600 degrees. So it is small in the sky. So 1 arc second times 1 arc second area will give an arc second square. This is the area of the sky patch. So this is the unit we use. Actually, this unit is used commonly, very common in the study of sky brightness. Also, as I said before, the accuracy is quite high, and we believe that each device is already calibrated by the manufacturer before you receive it. But please note that the manufacturer told us that the SQM has not been calibrated to a sky very darker than 23 magnitude per arc second square. This is not a problem in Hong Kong, but it may not be a problem in your regions. So we use the same device in the project, Go and Light Area project here. So I give you some technical details on the SQMLE. This is the spectral response of the sensor. And you see that this is wavelength, and this is the response. The solid curve represents the response of this device. You see that the peak wavelength of the SQMLE is about 540 nanometers. And the full hardness is about 2,400 nanometers. It's quite wide compared with the traditional CCD photometry. And that means the sensitivity drops about half of the maximum in this region. And when we compare the spectral response of the SQMLE to another filter bands, such as the Johnson V band commonly used in the traditional CCD photometry, we see that the dot curve is the dot curve is the response of SQLE, and can you see that? And the curve, this one is the V-band special response. So we see that the full hardness of SQLE is quite large compared with the V-band filters, and the peak wavelength are similar. So the peak wavelength of SQLE is 540 nanometers, and V-band is somehow 545 nanometers. So you see that the response of SQLE and V-bands are quite different. So someone proposed that we should have an offset between both measurements. So they find that the offset between both measurements depends on the spectrum of the sky and the cloud condition. Each range from 0 magnitude per arcsecond square to up to 0.6 magnitude per arcsecond square under certain condition. So this graph shows you the angle response of SQLE. They are the same, but in magnitude log scale and linear scale. You see that from the linear scale, this is the angle with angle. This is angle 0 degrees mean the zenith. If that means the zenith direction of this sensor. And you see that the full hardness of this sensor is about 20 degrees. That means for a light source 10 degrees away from the zenith. Let me say again, the sensitivities of the device drop to half of them when the light source is 10 degrees away from the zenith. This is quite wide from compared with the CCD telescope setup, but it is good for our measure because the light from the near the horizon or the building nearby will not affect our data a lot. So this is our setup used in our NSN. Since the device is not designed for outdoor use directly, so we design housing to store the equipment and protect it from the weather. And this is the case to store the SQLE. You see that the housing is quite large, larger than the one we are going to use. This one. Why? Because we store the network communication equipment and the power switch inside the box and put this outdoor. So please note that this is not the same housing we use in the project. But as Jason says before, we use a 3G communication for data collection. Why? Because there are a number of advantages for we to use the 3G mobile network because we can request the real-time data from every station, and which actually save our cost on routing cables from indoor to outdoor. So we are loaded to set up a fixed broadband internet connection for this device, which is because most of our station is not located in our campus. So we have to ask someone to for their permission to install the station and provide the power to us. But you can use a 3G mobile network for data connection. This increases our flexibility on station selection. So we are loaded to put a computer on site. It saves our cost a lot. However, of course, we need a larger housing to store our equipment and higher setup costs to buy the 3G mobile network, and also we need a network coverage. And we have some experience that the network may not be so stable under certain extreme weather, typhoon, and heavy rain conditions. So this map shows the distribution of our monitoring network. Actually, this is the picture taken from the International Space Station about 10 years ago. And you see that the distribution of the lighting distribution in Hong Kong is quite uneven. Most of the lighting concentrates here. Actually, the population density is higher in this area. This is Kowloon and the Hong Kong Island. So there is some lighting nearby. They are the country town or the so-called the new territories of Hong Kong. And we see that the red dot represents our urban station. We have 10 urban stations scattered around the city, and some of them is located near the business center. And we have 6 Euro stations in the dark area in this map. You see that this is a country park area, and some country park area is Lantau Island. And we have 2 long classified stations in the airport and terminal here. The lighting of these 2 stations are different from the urban and rural, so we classify this long classified, not neither urban nor rural. So for more details, you are invited to take a look on our project website and 2 journals article. Okay, any questions on our NSN project? Yes?
How can you supply the power with the 3G device?
Okay, each station need a power supply to power up the SKMLE and our network communication devices. So we ask for a power supply for each station.
So this station will not powered by like solar.
No, not powered by solar panels. We just use the common outlet from the power plants.
Have you ever calculated the power source with this device?
Yes, this is a good question. I will show you in the next couple of slides. The power consumption of not this, probably not this setup, because we won't use this setup in this workshop. But I measure the power consumption of the setup we are going to use. Okay. Any questions? So before we have lunch, I can show you more on our network.